Hey everybody, this is Mr. Munson, and we are in Unit 11, Area and Volume of Solids. So today we're going to cover surface area, lateral surface area, and volumes of these three-dimensional shapes. So let's take a look and get started. First of all, I'm going to suggest that you print up your very own geometry formula sheet. This is the one that was released with the 2009 SOL, and I think this is kind of what it looks like still. It's a rather large document, and to put on the screen here, so you can see it there. You're definitely not going to want to copy all that down. If you look down in the description box just below this video, I have a link for it, or simply you can go to Google and type in SOL formula sheet Virginia, and it'll probably be the very first selection. All right, look for the one that's a PDF. It's 2 pages long. There's the next sheet. And, making yourself familiar with where stuff is before the test will be very helpful, okay? Also, it'll be helpful for you as you go through this particular unit. Let's continue. So one of the I can statements that you're going to have to do is tell the difference between a height and a lateral height, okay? So these three-dimensional shapes don't have a lateral height, although it's kind of like one and the same. So this is the height of this cylinder. It's typically given. It's the same as the outside length, okay? So these would be the same thing. If I put a dot in the very center of the pentagon in this one and drew straight down to the center dot in the bottom, that would be its height. That height is the same as one of these edges, right? If I'm standing in the room, it should be just as high from the bottom, from the floor to the ceiling in the middle of the room, as it is on the edge of the room. I know we come up with a figure like this where we're looking at different information. And so on this particular one, we'll looking at the formula sheet. If you look at the formula sheet for shape, you'll see that a surface area volume doesn't exist. Now there's not going to be, and there's no lateral area volume formula. Okay, and so for a trapezoidal prism. But understanding what the surface area and the lateral area represents, you can find these things on your own. Okay, so if you're stuck and don't have a formula, you can go about doing it. We'll look at the using the formula here in just a bit. So what I want to do is realize that, first of all, these rectangles that make up the sides of this thing are the lateral areas. Okay, those are all the lateral areas. They're the pieces that connect the two trapezoids. So let's see if we can identify, what these things are. So first of all, they're rectangles, and there's 4 of them. That are exactly the same. And so both of them have the dimensions of 5. And then as I look up here to find this dimension, I don't see it. So I start seeking the one it is. So it's 4. Okay? Then there's the top and the bottom. And those two are 2 different ones. So I just have to use a little bit of skill to figure out what the dimensions of that one is. Then finally, there's one more rectangle that has the dimensions of 8 by 4. Now, if you have trouble figuring out what those dimensions are from the figure, that's why you're in geometry. If you shy away from stopping the video and trying to figure that out, instead of just writing it down, try to figure it out, you will own that, and you will be of the understanding of how to do this. Okay, so now it's just a matter of using the area formula to find those pieces. Now remember, those pieces, those 4 sides, represent the lateral area. We're just going to put them together. No formula, just find them, plug them in, figure them out, add them up. So after adding all that up, you get 84. Again, we're talking area, so that's the art of counting squares. 84 meters squares, or square meters. Okay? All right, so the next idea is surface area. Again, we're doing this without a formula just so that we could, if we don't have a formula sheet, or in this particular case, we don't have a picture of this on our formula sheet, so we have to still be able to do it. We have to understand what's going on. So we have this surface area that we still need to calculate. Now the cool thing is that we've already calculated part of the surface area. That's those rectangular pieces that go around. Surface area includes the entire shape, the lateral surface areas, and the top and the bottom, or the two trapezoids. So now it's just a matter of finding the area of the trapezoids, multiplying it times 2, and then adding it with the surface area. So here's my basic philosophy. So I'm just drawing a picture. I say my philosophy is kind of a plan. I'm going to find the area of those two trapezoids, add it to the already found lateral area, and we have it. There's my formula. So if I've done my math right, the area of that trapezoid should be 23.65 meters squared. And there I have it. The two bases, that would be the trapezoids, added to the lateral area equals 107.65 meters squared. Now I found it in chunks, but we could simply have found each piece and just added them up. Make sure that when you're looking at a shape like this, could you actually count the number of sides and then just find the area of each side and add them up. But let's look at doing some of these with the formula. Let's take a look at this problem here. Look on your formula sheet and see which formula would you use on this. Now, the main thing is this is a pyramid. So let's look at finding the lateral area and the surface area for each, or find for each piece, okay, or for the shape. So according to our form sheet, okay, so to find the lateral surface area of a diagram like this, when we look at a pyramid, the lateral area is 1/2 LP. So the thing that you really want to get out of this video is what does these L's and P's and the pieces represent in the formula, and then how do I find them when they're not given to me? Okay. All right. So in this particular problem, I need to find the lateral height. The lateral height is found by going down the side of one of these triangles. Okay. So what I want you to do is think of how would you find that lateral height? It's not given in this case. And so what you would want to pick up is this. There is a right triangle that's formed in this diagram. Here's the lateral height, that blue line. And there's a right angle here. And this is 11. Go find where that 11 is pointing. And then here's this 8.3, which is long from, it's basically the apothem. And so we would look at finding this lateral slant height. Okay? Pythagorean Theorem. Off you go. Now you probably went ahead and took the square root of 189.89 and found it was a decimal around 13 something. I am not going to go ahead and do that just yet. I'm going to hold on to it as a real number like this, where it's the square root of 189.89. I'm going to put it into my problem because I don't want to start rounding yet. Okay, so I encourage you to do that so you can come up with exactly the right answer. So we just need to find the perimeter now. Now I find that to be 60. So finally, I have all the, now I'm just going to stick all that in my calculator and let it do the hard processing. So if I did that right, I got 413.4 yards. So far that's incorrect. I don't have my correct units on there. I'm finding lateral area. That's area that's in art of counting squares. So I need to make sure it's square yards. So that's basically 400 so of squares that are 1 yard by 1 yard, 3 feet by 3 feet. Now that finds the area of kind of the top shell, the part that goes up to a point. It doesn't include the base. So if I want to do that, I'm going to use the surface area form, which is this formula. And since I've already found the surface area, you can see it's just adding the base to the surface area, to the lateral area. So since I've already have that, I'm going to bring that in just a moment. Let me go calculate the base area. As you can see, I'm going to use the regular Polygon area formula, which is that 1/2 apothem times the perimeter, which is 249 square yards. Okay, so let's go ahead and fill all the information into my surface area formula and be on our way. With a final answer of 662.4 yards squared. Okay, suppose this was a toy and I wanted to paint this thing. Be a very big toy. But let's say it was a toy and I wanted to paint this thing, top, bottom, all the sides, and I knew a can of paint covered 20 square yards. how many cans of paint would I need? So I take that surface area, 662.4, and I divide 20 into it to see how many cans I would need. And it comes out to be somewhere around 33.12. We never round down. We will end up short of paint, so I would always buy up, and that would be 34 cans. Suppose this was my house. Well, if it was my house, I'm not looking at painting the inside, just the outside, and I wouldn't paint the floor underneath. That's where the dirt's at. So I'm just looking at the lateral area in this case if I was looking to paint it. Let's move on. All right, let's take a look at doing the lateral area and the surface area of, say, a cylinder. Go ahead and find the formulas for that. Let's do them individually. Come back and check me in a few seconds after you've done the work and see if you got it right. Okay, and there you have it. I got 175.93 units squared after taking it from being in pi form, in terms of pi. I want to point out the units here. Since I look at the picture and there's no units, I can either put a u squared or a un squared. It doesn't matter, but you want to put units on there. Don't leave it alone. Over here on the surface area, I found the final in decimal form to be this. Now here's an interesting thing. If I asked you to find the amount of paint it would cover this thing, let's say this was like an oil tank, out in the field someplace, I definitely would want to cover all the sides, right? And that would be the lateral area in one of the circles. If I use the surface area formula, you'll see that it's actually calculating 2 of the circles. So I'd need to do some calculations. I might find the lateral area and then find one of the circles and just add the 2 units together. So let's look at doing a volume of a shape like this. Now again, we don't have a formula for this, but we can come up with the idea. What I've told you in class is that we could find the number of squares it takes to cover this thing, the main base here, and then we'd just stack boxes up against the wall here, and that would tell us how many cubes go up against the wall, and then we just simply multiply it times how far it takes us over to the adjacent base wall, and that would give us the total volume. So see if you can do this one, figure it out on your own, come back and check your answer. Now in a previous part of this video, we've already found out what the area of that thing was, so I went ahead and calculated. That's the formula I used. I take that back, I had that number wrong. And so it is 23.65 for that one area. And that just made me realize that in a previous part of this video, I was finding the surface area. I forgot to multiply that times 2 because there was 2 of those trapezoids. So if you were walking through that with me and realize that, fantastic, you totally understand this, right? I should have multiplied that times 2. If you're not sure what I'm talking about, then go back and look at where I was finding the surface area of this thing, and you'll see where I came up with this as the surface area, but that's the one for that's the surface area just for one trapezoid. So according to my calculations, there should be around 23.65 squares if I'd drawn that correctly. And if I stack boxes up against this thing, I would have 23.65 boxes. And then I would have, because this is 4, a length of 4, I would have 4 of those, 4 levels of that 23. So what I'm going to do to find the volume is I'm going to do 23.65 and just multiply it through, and I get 94.6, and since this is in meters, we're going to make that cubes. And so that's pretty much it for those kind of shapes. And then looking at a shape like this, we have to be a little bit careful on the pyramids. We have the volume of the pyramids, which is 1/3 base area times its height. So after doing a little calculation of the base area, you can put me on pause and take a look at those calculations and put them in your notes. I'm going to take that and stick it in for the base area, the big B. In this formula, the height is not the slant height, but the actual height of the pyramid. I just simply plug it in that way to my computer or to my calculator, put in parentheses around that, so it's 1 divided by 3, close parentheses, and then 249, and that ends up being 913. And since we're talking volume, it's 913 cubic yards. Now, one of your I can statements is that you can find the volume of what we call a compound three-dimensional figure. So what I'm going to do is I'm going to take objects that you should be able to find the volume of and put them together like this. And so you have to kind of see them as pieces. And so in this particular problem, it's half of a sphere and then a rectangular prism. Okay, so you'd want to find the volume of this kind of shape. These shapes and then add them together. Okay, so you have to be able to look at it from pieces and figuring it out. Now, if I ask you to find the surface area of this thing, that's going to be a little bit more difficult because you have to think about it's just covering stuff that's visible. So I'm not going to necessarily find the entire surface area of this top part. I'm going to subtract away that circle part. Okay. Now that's a really difficult question, and just in the sense of time, I could see that as being a bonus problem or whatever. But in this sense, what you would have to do is know what the radius is of this circle. So you have to steal that measurement. You have to recognize that the diameter of this thing is the same down there. So you have to kind of be able to see that. Okay, so the radius in this case would be 4. How about a shape like this? Can you see what it is? So if it's a volume, then again, in this case is again another a half sphere, so you'd find the volume of the sphere. Then you would have also a cone volume that you would have to find. Okay. All right. If this was surface area, then you might find the surface area of the sphere, but then take a half of it because you only need half of it. And then for the cone, you'd be finding only the lateral area. All right, nice job. This one's about, 17 minutes long. You've done a great job. A lot of information. Let's see if you can put it to test tomorrow or in the next class in the practice problems. Do these problems, bring them to class. I'm going to scroll through it so you can see it in a little bit bigger format. Have a great day.